So, good evening and welcome. My name is Attila Hideg. I'm from the Budapest University of Technology and Economics, and I will talk about the mixed reality spectrum and how can it be used in the industry, and I will show some applications and ongoing projects which we're currently experiencing with. So, what is the mixed reality spectrum? This spectrum lies between our physical world and the virtual reality. Our physical world is what surrounds us. For example, this room, the tables, the chairs, and we already have some digital content in it. For example, we have devices. We have a mobile phone. We have this presentation here. It's digital, so we added some digital content to our real life. On the other end of the spectrum, the virtual reality, but the closest thing is these head-mounted devices. These headsets can be used to shut out the physical world. So with an earphone, you can not hear your surroundings. With these headsets, you cannot see your surroundings. So as they say, you can immerse in a whole new experience. Usually used in consumer electronics, but in the past decades, it was used for trainings, for example, pilots or astronauts. And it's not a matrix like virtual reality, so you can still feel your surroundings, and you can still sense heat, you can smell. But this is an iconic image where the CEO of Facebook went through the crowd without them noticing him. And as we're moving towards this virtual reality, the first step is utilizing the phone's camera and its display. We can add some virtual elements, some simple text or complex objects, and we extend our current physical world. If we move closer to the virtual reality, well, these devices, which has see-through displays like the HoloLens, you can look everywhere in the room, and you can feel digital content. So you can place the weather forecast on the table, you can place a stream on the wall, and as it displayed in front of your eyes, wherever you look, you can see these digital elements. And as we move closer and closer to the virtual reality, we start to speak about augmented virtuality, referred as XR, which is not a certain point. It's a bigger slice of the whole scale. And in this case, the physical elements in the room affects the virtual world. For example, if there's a furniture right in front of me, it can appear in my virtual world. There are already some XR headsets announced, which has cameras in it, so it scans the room and it can project in the screen. The first usage of augmented reality was using phones. As their cameras are getting better, their CPUs are getting better and better, we can recognize images. And recognizing images can be used to use them as image targets. For example, we want to put something on the floor, or we want to have an ID of a room. So we put an image target, and we know where it is, what it is, we have an ID, we can put objects on it, texts on it, and it's a really cool app. I don't know if you have seen videos, if you tried the measuring tool, where you can just point to points in the world, and it tells the distance between them. And the next step is these see-through displays, like the HoloLens, which has two 2HP displays, and to map your surroundings, it utilizes 4 environment understanding cameras and 1 depth camera. So it scans your surroundings, it creates a mesh, and it will utilize it. And then you put objects on it. For example, you can put an object on the furniture, you can put objects on the walls. So it can snap it because it knows and already scanned that part of your area. And what can we use the HoloLens for? And the first proposal was medicational and educational usages. For example, I have a 3D image of a body. But in the medical books, there are thousands of images, slices from organs, from the neural system, from the skeleton. But if it appears in front of me, and I just take some bones, enlarge it, view the their orientation or how they connect with each other, it's way easier and way better to understand it. So the educational purpose is clear. But can we use it in the industry? And we wanted to see if there are possibilities to use it, and we have some ongoing projects and some demos which utilizes the HoloLens. One of our first projects utilized its connection. It has a Wi-Fi connection, a Bluetooth connection, so it can connect to a cloud service, it can connect to a computer or the devices itself. For example, in one of our labs, we have this factory belt, which has sensors. It can move, so we can put input for this factory belt. And if we project the data, the sensor readings in front of us, we can decide what we want to do based on them. For example, we know that there's an item at the beginning of that factory belt. So we might decide that we want to move the item a bit further. So we just press a button, and because of its connection, it already sends that item. Another usage is when you want to educate or teach your new colleagues, or the technology changes or the best practices changes, you want to adapt to these changes. And if you have a step-by-step guide visualized in a three-dimensional area, it's really easy to understand what happens. And maybe without proper understanding, you can still follow some basic steps. So, for example, when a new colleague arrives and you have to transfer some knowledge, and he goes to the most important machine on the department, which is the coffee machine, and there's a red light with a red signal, and he doesn't know what to do with it. So you introduce him to the coffee machine using an application which also could read some sensor readings, but the most important thing is based on an image target, which he has to find. He knows where that machine is, and right after it knows what he has to do. For example, there's the coffee machine, and he has to check the water level. To check the water level, he has to open that lid. And this step-by-step instruction can show him what he should find there, where he should interact with that certain machine. And without any knowledge, so he doesn't have any a priori knowledge, he can brew a delicious coffee. And because the HoloLens does not require to be held in your hand like a phone, you can utilize both hands while still seeing those digital content which you want to show them. So, for example, let's take a printed circuit board which a colleague has to finish, but he doesn't really know how to. He has some general knowledge in the area, so he knows how to solder, what is an IC, and to finish it, there's a three-dimensional model which shows that he needs to put that certain IC there, and because he has his two hands free, he can quickly finish it, and as you can see, he completed that part of the procedure. Okay. So the next usage is well, on this, because the HoloLens can scan QR codes, and you know the position of the QR code, you can show him, like in this red box, you show that he should open this lid or pull the drawer, and he can find that IC there. And you can scan those QR codes, so you know how many IC he used, where he is, or he can immediately know if he taken the good item or the wrong item. And during the manufacturing process, there might be some faults, and it's a really important task to have a quality assurance. And for example, when you're building cars, and there are some errors which has to be corrected at the end, you can mark it. And if you have a three-dimensional model of a car, and you can quickly say that there's a problem with the painting on the hood. So you select that car, which is right in front of you. Yeah, that's not that certain car, but okay. So you see some errors with the painting. You mark it in a three-dimensional model. You can add notes. You can create audio logs or videos. You can reproduce the problem. So in the end, when the inspector checks what the problem, it's immediately shown to him that there's a problem in the hood, or that certain more complex problem can be reproduced that way. This was one of our first projects where we had to show a real world, show a network in the real world. We have custom points of interest with GPS coordinates. They are connected, and these points of interest can be like electric boxes, or the connections can be gas pipes, so whatever the network requires. And these points of interest has custom data, which has to be shown when they are next to it. And our main task was to visualize that network. And when we went there to the field, it was pretty cool, because we saw that there might be a gas pipe here, because our application said it. And we saw the digging marks on the ground. And we knew that there was that pipe. And when they said that at least 2 guys need to be there when they're performing this maintenance, now only 1 guy is required, and he sees the network using the HoloLens. And if we add some Bluetooth or Wi-Fi connectivity to those boxes, it can immediately have sensor measurements, for example, transferring them, so 1 guy can do this whole process. But this project had lots of challenges, and the main challenge came from that the HoloLens was designed to be an indoor use only. So it cannot see too far. It does not act with mobile data, nor GPS, nor compass. So you know that the problem can be solved with workarounds. For example, you share your mobile data using a phone. You can have a Bluetooth GPS, but as it was previously shown, it's not accurate. So somehow you have to correct those small errors, for example, that 4 to 6 meter precision, imprecision. And even with that, we don't know where the error can come from. It can come from the HoloLens itself, from the GPS position, or the values from the server. And it's still an ongoing project, and we really want to know how we can improve this precision. And the last demo I want to show is a medical application. There's a certain file format which is called a DCOM file. And it contains medical data in a strict and standard way, like the patient's name, his social security status, its health issues. And the most important thing is it has CT and MR slices. And what we wanted to achieve is to have a 3-dimensional model from these slices. So first, using an application, we applied Marching-Cube's algorithm for these 2D slices and recreated a volumetric 3-dimensional model. Then we had to optimize it. Because the HoloLens's computational power is not that big, we had to use low poly models. And after it, we could render the final body in the HoloLens. And this is that application. You can see the 3-dimensional body in front of you. And if you go close enough, you can look inside the body. So you can check its internal organs, whatever is digitalized. And we can put additional data. For example, we can put his name, it's John Doe. His diagnosis is a brain tumor. We can attach a Bluetooth device, for example, a heart rate monitor or an EEG. We can go through those standard CT slices, like in a standard way, so it's just 2D images. Or if he wants to check them in 3-dimension, he has the option to move 2 planes. And moving these planes helps him to find the precise position of the tumor, which I believe is that white spot inside the brain. And he can also check that brain tumor in the 3-dimensional model, which is inside his head, as you can see it. But turning off and filtering, for example, the skin, the bones, and lastly the brain, you can see that tumor. And the same way as we could put errors in a car, we could mark these problems. For example, he can add a note that this is a brain tumor, or he can make a proper diagnosis. And the main usage would be that before surgery, when the surgeon comes and puts on the HoloLens and see the three-dimensional model, he knows exactly what his medical status is, where the problem is. He might even decide that he wants to penetrate the skull from this way, or he just could use it as a preparation. That's it for today. We still have lots of ongoing projects, and we still want to utilize the HoloLens's capabilities. Thank you for your attention, and if you have any questions, feel free to ask. Thank you.